This is the scapula. You are viewing it from the back side. As you see, the scapula is a triangular bone. It has got a superior border, a medial border, and a lateral border. Lateral angle of the scapula is the glenoid cavity. And you are seeing the dorsal surface is split by a shelf, which is called as the spine of the scapula. And this spine of the scapula separates the dorsal surface into a supraspinous portion, which is here, and an infraspinous portion. And the spine of the scapula widens on the lateral side and curves forward, and this is known as the Acromion process. The spine of the scapula also forms a notch with the glenoid cavity, which is called as the spinoglenoid notch. So this is the dorsal view of the scapula. And here you see that the glenoid cavity is actually a pear-shaped cavity with a notch on its anterior margin. Then, if you see the anterior surface of the scapula, you find that the anterior surface is concave and it is sloped like this. It is sloped like this to the slope of the chest wall. On this side is a finger-shaped process. It's a finger-shaped process like this, and this process is called as the coracoid process. So now we will start recognizing that this is the glenoid cavity. This is the infraglenoid tubercle. This is the supraglenoid tubercle. This finger-shaped process is the coracoid process. This is the suprascapular notch. This is the superior border of the scapula. This is the medial border of the scapula. And from the inferior angle of the scapula, this is the lateral border. And so this is the forward and backward view of the scapula. And if you want to hold the scapula, here is the human body, then it is at 30 degrees to the coronal plane of the human body. Now, after this, let us try drawing the scapula. So you are drawing from the front, and this is the glenoid cavity. Here is the supraglenoid tubercle. Here is that finger-shaped coracoid process. Here is the suprascapular notch. Here is the superior border. Here is the medial border. And here is the lateral border of the scapula. From behind the scapula, you find that the spine of the scapula will come. The spine of the scapula will come from behind it, like this and like this. And then it will turn forward and create a process which is called as the Acromion process. So this much part of the Acromion process may be visible from in front. Now what we will do is that we will put the articular cartilage on the glenoid cavity, which is concave, and this is the articular cartilage. And on the side you have the glenoid labrum like this. Now what we will do here, that we will place the head of the humerus into this to create the shoulder joint, and here we will put the greater tuberosity, and here is the medial border of the humerus, which will end in the lateral and the medial epicondyle. Here will be the capitellum, here will be the trochlea, and here will be the coronoid and the conoid fossa. Here will be the bicipital groove, and here will be aligned with the scapula, the lesser tuberosity and the bicipital groove will go downwards. Now, on this we will start placing the capsule. So here is the capsule and here is the lax part of the capsule, and then the tendon of the biceps, the long head arises from here. It comes down the bicipital groove, held on to the bicipital groove by the transverse bicipital ligament, which merges with the capsule, and the short head of the biceps comes from the coracoid process, and so you have the two heads of the biceps muscle. That's why two heads means biceps, two heads. Then we would like to place what is visible on the greater tuberosity, and the supraspinatus is visible here. So it is the supraspinatus, infraspinatus and teres minor which will be attached to the greater tuberosity. As you see, the teres minor is the lowermost. It will be arising from the lateral border of the scapula, and here you will see the teres minor muscle. The teres major will be attached to the medial lip of the bicipital groove, and so this will be the teres major muscle. Okay. Now, from the infraglenoid tubercle will arise the long head of the triceps. It will go behind the teres major and get attached to its lateral and medial head. In line, therefore, a quadrangular space will be formed here, a medial triangular space will be formed here, and a lateral triangular space will be formed here. On the posterior surface of the radius, in line with this lateral triangular space, you will have the radial groove going downwards and forwards. The latissimus dorsi muscle will turn around this inferior border of the this is the latissimus dorsi, winding round the lower border of the teres major and going to get attached on the base of the bicipital groove. Okay. I have told you that through this there will be another muscle which will get attached to the lesser tuberosity of the humerus and which will arise from the anterior surface of the scapula. Now, if you place this muscle, you will find that this lax part of the capsule is sandwiched between the teres minor and the subscapularis muscle. So this is the subscapularis. So this sandwich, the subscapularis, the lax part of capsule and teres minor, forms the superior boundary of this quadrangular space. The medial boundary is formed by the long head of triceps, the inferior boundary by the teres major, and lateral boundary by the surgical neck of humerus. This quadrangular space passes the posterior circumflex humeral nerve and posterior circumflex humeral artery. and the lateral triangular space passes the radial nerve, which goes into the radial groove, and the profunda brachii artery, So this anatomy, nothing passes through the medial triangular space. The circumflex artery actually pierces the teres major muscle and goes on the posterior surface of the scapula. So this is the circumflex scapula. Then from the medial surface, medial border of the scapula arises a muscle, and this muscle goes around like this and gets inserted onto the rib. This muscle is called as the serratus anterior. It actually would pull the scapula forwards over the thoracic cage. So it's a muscle which is the boxer's muscle, where the scapula protracts to give the power to the punch of the boxer. Then you have the levator scapulae attached here, the rhomboidus minor attached here, and rhomboidus major attached here on the medial border of the scapula. On the superior border, nothing is attached, but on the medial part of the superior border, you have the transverse scapular ligament, and just on this side, the inferior belly of the omohyoid is attached. The nerve passes through the suprascapular notch, and the suprascapular artery passes above the transverse scapular ligament. So this finishes the anterior view of the scapula as we saw it. Now we will proceed to see the posterior view. The posterior view of the scapula we will make like this. So we'll make the boundaries. Almost we have made the boundaries. Here we will make the glenoid cavity. Here we will make the suprascapular notch. And from here we will bring the spine. Here will be a tubercle on the spine, which is the deltoid tubercle. And the spine would be going like this and converting itself into the acromion process. And this suprascapular notch would lead to the supraglenoid tubercle and the glenoid on this side. And here will be the spino-glenoid notch, and this is the boundary that you are seeing. So this is the scapula from the dorsal side, and you would find that if the humerus is here, then the supraspinatus muscle will arise from here, and it will go and get inserted on the superiormost part. The transverse scapular ligament would be here, and it would give passage to the suprascapular nerve, supplying the supraspinatus, and then coming through the infraglenoid notch, spinoglenoid notch, and supplying the infraspinatus. Same way, the artery would emerge from top, the suprascapular artery, and supply the supraspinatus and infraspinatus. It will anastomose with the circumflex scapular, and on this side you will have the levator scapulae, the rhomboidus minor, and the rhomboidus major. Then the infraspinatus muscle will come and get attached from this area. So this is the S, this is the I, and the Teres minor will come and get attached from this area. Then you will see that the long head of triceps is coming from the infraglenoid tubercle. Initially it is ahead of the anterior to the Teres minor. Then it becomes posterior to it, more prominent. And here will be the radial groove, the nerve. And the radial groove, which will be piercing the lateral intermuscular septum at this point and becoming anterior. And of course you will be able to see the teres major arising from here and going ahead of this, going ahead to get inserted into the bicipital groove on the anterior side of the humerus. So this is the teres major. Then you will find that the latissimus dorsi would come like this, big muscle, wind round the teres major and get attached lady between two majors. So this whole muscle, this is the latissimus dorsi. Then you will find that the circumflex scapular artery will pass through this. Nothing will pass through the medial triangular space, but from above the quadrangular space. So this nerve is coming below it, and from above it you will find that you will have the posterior circumflex humeral nerve and the posterior circumflex humeral artery through the quadrangular space. So this is the lateral triangular space giving passage to the radial nerve and the profunda brachii artery, and this is the quadrangular space giving rise to the posterior circumflex humeral artery and posterior circumflex humeral nerve, which supplies the teres minor and the deltoid. Now the deltoid muscle will arise from the inferior border and from the acromion and from the clavicle on this side, and this deltoid muscle will cover all these structures and get attached to the radial tuberosity. So this, then finally in the scapula, all this will get covered by a muscle which arises from occiput to T12, and this muscle is the huge muscle which is called as the trapezius, and it gets inserted on the superior border of the scapula, spine of scapula, and it also gets inserted onto the tuberosity. So when this pulls below, this pulls down, this pulls this whole end down, and this pulls the whole end up. So on this axis of the deltoid tubercle, the whole of the scapula would rotate in overhead abduction of the arm. I think this is about the scapula.